So, about 2 years ago, I was sitting at my desk thinking, what could I make in Minecraft that'd be pretty cool? So I made a QR code generator. Since its conception in 2022, I've remade this project a sum total of 3 times. I had spent way too many nights scratching my head trying to work out the bugs, but it's finally done. I'm not sure if I ever imagined getting to this point, as it always seemed really quite far in the distance, but it's finished and I'm super excited to put this video together, as a showcase for Project QR has been long overdue. Before we go on with the rest of the showcase, I wanted to say that this QR code generator, while the lamp display works and you can scan an actual QR code off of it, it works better if you have a QR code resource pack installed. So I had a friend make one that turns lit lamps into white pixels and black lamps or unlit lamps into black pixels. It makes it look way better. So let's take a look at how that looks. All right, and that looks like a real QR code. So we'll be keeping these on for the remainder of the video, just so that any QR codes that we generate in the future will be easily scannable by anyone watching. So to actually use this machine, we've got to be able to type in our text that we'd like to turn into a QR code somewhere. And so I've got a little keyboard over here with these note blocks and all of these signs detailing 95 of the 191 total characters that you can write. It's all just ASCII from the Latin 1 character set. And then here I've got a display that shows what you're actually typing before it gets encoded into the QR code. So like I said before, this keyboard has 91 of the total possible characters that you can write. And then I've got another additional input panel over here with a book containing all of the other characters that you can write and their hexadecimal values here, so that you can write in the corresponding ASCII binary into the main memory. I would like to point out that this display here, it was not made by me, it's made by CadenJB. It's a 16-segment display that works really well for reading the text that you're going to be entering into the QR code, but I just wanted to say I'm not taking credit for this part, as it is not my design. So to actually generate a QR code, all we need to do is type in some text using these note blocks, and then we just hit generate. After that, it'll take about 2 minutes to fully generate the QR code, and the display over here should update. I will say that because the display is a fixed size, there's a fixed amount of characters that I can add into the QR code. For the specific parameters I've chosen for this specific machine, you can only add in 17 characters into the QR code before it fills up. And so without further ado, let's add in some text and hit the generate button. And while it's generating, I'll be able to explain a little bit about how it works. So I think let's do a smiley face. So here's a colon, so I'll hit that, and then we should see a colon character come up on the display. There it is. And then here's a bracket that we can choose for the smile. That bracket should show up right about now. Perfect. All right, and all we got to do is now hit the generate button. So the first thing that happens when you type in text is it goes into these two ROMs. This ROM here contains the actual ASCII data, which gets bussed over to this RAM, which stores the ASCII data before it gets converted into a QR code. The back part of this ROM here are the 16 different segments for every character of the 95 that are on this keyboard, and that gets bussed into the display. After you hit the generate button, the data gets sent in over 2-tick serial down this brown line into this guy, which is the data formatter. There's a few things that the data formatter does, but it shifts the data into the correct position, adds some extra information data based on the size and type of error correction inside the QR code, and it adds in some pad information that is needed per the QR code specification. After the data formatter receives all of the data, it gets sent along this white line, basically retransmitted, and sent to the actual QR code. So in a few seconds, we should see the QR code, part of the QR code update containing the new message. Let's see, we should see it relatively soon. It might have updated already. It might just be a visual glitch. There it goes. And so that's the new message data. And now all we have to do is wait on the error correction data, which is done by this guy, this giant orange, all the cyan, and the light blue, green, all of this. The error corrector is based on generating Reed-Solomon error correction data, which I will post a few links for in the description for you to read about it. It is a little bit complex, and I think it'll take too much time in this video to fully explain. But if we go down here, we should be able to see which step it is on. The main part of Reed-Solomon error correction is basically a polynomial division, and there are 19 steps in that division because of the amount of data inside our QR code and the amount of error correction data needed. So once this line turns off, that means the error correction is done. Looks like it's got just about two more steps to go until that error correction data is done. Once the error correction data is done generating it, it gets sent along this black line, which again is another 2-tick serial. Oh, looks like it just finished. So this black line should start flashing with the new error correction data in it. Should see that happening. There we go. And then this data gets sent all the way to the back of the QR code, where it should update the final portion of the QR code, making it a scannable code. So I'll just hit F1 and wait for that to update. Oh, look, there it goes. The back of this display is a little bit large, but you can kind of see where the message data fits in and where the error correction data fits in by looking at the white lines, which are for the message data, and the black lines, which are from the error correction data. That gets bussed in, and then we have a scannable QR code. So I'll just sit over here for a second, hit F1 if you want to scan it. The specific type of error correction that I've chosen for this QR code is, well, it can correct around 7% of the message, including the error correction data itself. So what I think is cool is I can just change some of the bits here. Let's, for instance, maybe turn these two on when they should be off. And this QR code should still be completely scannable. 7% of this message is around an entire byte, so that would be 8 of the pixels that are in this QR code can be completely changed, and it will still be scannable, which I think is really cool. So for the final portion of this video, I just want to go over a few key features that made this build possible, and specifically the speed at which it's able to compute the QR code and the size of this entire thing being, well, relatively small compared to my previous versions. One of the most important features that I included into this build, but it's probably one of the smallest, is that everything is pretty much spam protected. So if I decide to hit the generate button and I accidentally hit it again during the generation, nothing is going to happen. In addition, we've got in the keyboard, we've got a backspace button. Of course, that's useful when you're editing your text, and if you've written out an entire 17 character string and you want to get back to the beginning, you can always just hit the clear ASCII display button. That's a lot better than hitting backspace a bunch of times. In addition, the backspace button won't work if you're at the beginning of the message, and if you try to write more than 17 characters in, it just won't let you. And then as soon as you hit the generate button, all of the buttons here, including backspace, the clear ASCII display, and the entire keyboard, and the additional special character keyboard over there will completely lock up, making sure that the machine doesn't break and you can't change the message while the QR code is generating. Of course, after the QR code is finished, all of the buttons will unlock again, allowing you to generate a new code. One of the key features in this build that made it possible to build this at the size and the speed that it currently is are these ROMs here. This is a ROM that's used in the error correction generation. If you'll notice, it doesn't look like your normal Redstone ROM. I've got a normal one over here where you'll recognize it based on the decoder lines going upward, and then each of your data lines here, and of course the busing of the data all the way to the output that goes perpendicular to those. These are great, but they're huge, as you can tell. This is actually the V1 that I mentioned before, and yeah, the ROMs really make this way bigger than it needs to be. In the version 2, I actually made a smaller ROM, but it was still pretty big. It's down here. So this one uses a staggered design, so all of the data lines are staggered instead of being in line, and that reduces the size of the ROM significantly, but not significantly enough. And so I created this one, which is way thinner than the original, and it's actually faster. So these ROMs are used in the main error correction generation, and it allowed me to pipeline the entire division process and of course squish it into this tiny space. Trapdoor ROMs have existed. I've seen many people use them, but one thing that I haven't seen too often is people using both sides of these walls to transmit the signal downwards. It reduces the length of one of these trapdoor ROMs by a factor of 2/3, which again greatly reduced the size of this build. And that basically wraps up the showcase. And before the video ends, I just want to extend a thank you to everybody who helped on this project. There are so many names, and I won't be able to list all of them off now, but I am going to include them in the description. And so thank you to all of them, and most importantly, thank you to you for watching this video, and I appreciate it. In addition, if you want to ever come check out this build, this is actually built on a server. It's called Stym's Redstone server, and I'll put the IP in the description, and maybe it'll pop up somewhere on screen. But there'll be a warp and a command that you can use to actually get here. And once you do, there's this little sign that says, click here to download the QR code resource pack, and you can click that. I have my chat off so you can't see it, but a link will pop up in the chat where you can download the resource pack that I've got on right now. And with that, just thanks for watching, and I'll see you guys in the next video.